Hey guys.
Hello.
So today we're going to be putting together a ToyMod kit, and this time around it's the
TurnMe quadrature encoder module.
So what the heck's a quadrature encoder?
Well, that's a good question, Whisker. What is a quadrature encoder?
So let's see. With the kit you're getting some current limiting pull down resistors, yeah?
Yeah.
A couple of nice headers. These are the round, thin ones that go into breadboards really easily.
Yeah.
And a Tymkrs ToyMod PCB.
Yep.
And a rotary encoder.
Yep.
Quadrature encoder, if you will. So this thing has like detents. You can feel it click, 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 click as you turn it.
Mm-hmm.
And every time you turn it, a different binary pattern comes out on the output pins. There's 2 pins there. And it's like 1 0 0 1
0
0 0
1
1 1.
Okay.
And depending on from which pattern to which pattern it went to, it knows whether it turned left or it turned right since the last time it saw it.
I see.
And through that, with a little bit of code, you can determine how many times it's turned left and right.
Yeah.
Okay?
Mm-hmm.
So it's a sort of an infinitely spinning controller that you can use to control menu systems and turn volumes up and down without actually putting an analog signal through a crackly potentiometer.
Mm-hmm.
You know, whatever you're going to use it for, there's a million different things. It also has a switch in it when you push,
Mm-hmm.
and that turns on the 3rd pin there.
I see.
So,
And I think when you press and turn, that also...
yeah, well, if you're pressing and you know you turned left,
Yep.
then you can do something different than if you weren't pressing and you turned left.
Right.
So by that you can do a 2-tiered menu system where you push and turn to change which menu you want to select,
Right.
and then you don't push and turn to change the value of that submenu.
That sounds familiar or similar to one of the pieces you had in your SIDCOG organ.
Yes,
Is it the same thing?
It's the same basic idea, and we're working on a synthesizer kit that will include that, which is of course why we designed this. But like all the parts that are going into our synthesizers, we're designing them such that all of you get a chance to play with the parts and not just the synthesizers themselves. You can design your own synthesizers.
Mm-hmm.
So that's nice. So basically what we're going to do here is we got these 3 resistors. They're all the same value. So I'm going to pull them out here. And you fold over the leads. And you can see on the silk screen on the PCB there's little white squares that have R1 through R3 on them.
Mm-hmm.
These are all the same values, so I'm not going to be too picky about which resistor goes where. But when I put them in, I fold over the leads so that this stays nice and neat. I also like to put all of the resistors in the same orientation. Not that it matters because they don't have polarity,
Right.
but it looks really good at the end of the day when they're all going the same way.
Right.
Makes it a lot easier when you fold these over. A lot easier to solder.
Mm-hmm.
Everything stays put. You don't have to hold anything. You don't have to worry about doing anything sneaky, tricky, whatever. All just works. So we've got 6 solder points between those 3 resistors. We've got some 60/40 very thin solder. We've got our soldering iron set up to 350 degrees Celsius. I haven't used this in a couple of days, so I should probably tin that. There, now it's nice and shiny, it's ready to go. We just set it on the metal of the pad and on the solder at the same time. I should say on the pad, on the leg of the resistor. And then we touch the solder to it. It's super easy. should make Addie do these videos.
I can solder.
She can show you guys the super
the best way to do it.
Addie soldering method.
So when would you choose to use a quadrature instead of a resistor? So obviously the quadrature is able to
You mean a
rotate.
potentiometer?
Oh yeah.
When you want a very digital controlled result, something like this is much better. When you want a analog signal to go through it, obviously a potentiometer is what you want. Alright, so we got that put together, and I'm going to clip these off, and we'll take a photo of the results so you guys can see it. Alright, so those are in, and now I'm gonna install the quadrature encoder. There's 3 pins on one side, 2 on the other, and then there's the big ones that go through the board that are like physical connections for this guy.
Yep.
And it should slide pretty easily right in there. You don't want to force anything when you're assembling electronics. Yeah, that went together really easy. So we're just going to set this on here. And then we've got those 7 solder points we need to take care of. Now for the small ones, just the normal pins of it, I'm going to use the same temperature as we were using before, but when I do the bigger ones I'll give it a little bit more heat because there's a lot of metal there. Save myself some trouble. Out of all the kits we've done so far, I'd say that this is probably one of the easiest to assemble. Because it's very straightforward through hole.
You pretty much can't get it wrong.
Oh, you might be surprised. We do put these videos together for a reason, because the first time you install a kit as a hobby guy or hobby gal, you probably will make some mistakes that will impress anyone that you tell about later. They'll be like, no, really? You actually did that? And you'll be like, I didn't know better. So I'm just filling this completely with solder around these legs because that's a physical connection. And that's where all the stress gets taken up. So we want to make sure that that one's nice and strong. And I'll take a little photo of this for you guys so you can see up close what it's supposed to look like.
Okay.
So we've got that all soldered up. Everything is looking good. Looking nice.
So with this, there are a couple of options. You can either panel mount the quadrature encoder, or if you want, you can make it breadboard friendly. And so Whisker's going to show how to do that.
So on our standard breadboard that comes with these things, with our included little small gold breadboard header pins, they'll fit into these holes, and you can use a breadboard as a sort of jig. And you just set that down onto there, and then you solder all the pins in place. Now one of these is just for structure, this backside here, and then one that has the minus, SBA, and plus, that's the one that you'll actually be making sure that your wire's hooked to. There's any number of ways that you could do this. You could, for example, solder wires to these holes, and then drill a hole through a panel, and then put this through and tighten down that nut, and then you'd have a panel mounted rotary switch with nice handy wires coming out of it. You could also do some sort of a 5-pin female header or what have you. There's a lot of things you could do. This is just the breadboard version, and I'm not going to solder this one up because I'm actually going to be doing this as a panel mount for another prototype I'm working on. So that's all the soldering. Now let's get to some demonstrations, and we'll use one that we've already soldered up in breadboard configuration as our demo unit for that.
Okay, so here we have the Turn Me board, and we just added a little chicken head knob on top of it. We've got power and ground connected, and then the S, B, and A are connected to just 3 pins that our demo code is keeping track of. And the demo code is available on the toymaker.com/kit website under the Turn Me link. So I'm just going to turn this to, I think, the right and then the left.
Yep.
Okay.
So you can see the numbers are going up as she turns it that way in the first column. Turn it the other way, the numbers will go down. Now to change the second column, she can push and turn. And there the numbers are going up. And the demo's modulo, so that when she went below 0, it kept going down. Now you could set this up to do anything. This is just what the demo's doing, because we thought it would be an easy example to show people how to get access to both at the same time, the pressed and the unpressed, and both directions for each.
And there you go.